So if anyone has left, please join. Chetan, please tell him to join. Okay. So if you join late, this is the problem. Okay. Yes, here we are. We'll just give a brief introduction about numerical analysis. So you can see this is helpful. Yes, where we are studying the finite difference. Why we study all these things? I'll just brief the idea. To estimating accurate value of the dependent variable corresponding to a value of independent variable. Yes, students, you can see I'm going to take a function where one independent variable we have and another dependent variable. Then we can just see how this finite difference is helpful. So this will help you to find estimating as well as calculating the accurate value, okay, of the dependent variable. So this is also helpful for obtaining the definite integral of unknown function. So here also, where everywhere in mathematics, x and y they take, right, and many have the queries that why they take x and y. They don't ask, but I ask everyone that why we take x and y. Yes, anyone? Please tell me why we take x and y maximum time in mathematics, especially, or in any other calculation or numerical calculations are there. Yes, in various fields of engineering, why we take x and y? Yes, the answer is very simple. Whichever the term we don't know, we take x and y. That's a simple idea. Just for this thing, we just take it as x and y. So x is any value, let y be any value, right? So therefore, we take x and y. So next, very important for finite difference study, to study finite difference, we come across finite difference while solving an engineering problems, physical problems are there. Course of an experiment having a data comprising a set of discrete values of a dependent variable corresponding to various values of independent variable. Students, yes, you come across various experiments, right? So you collect some data, it is in the numerical values, right? You try to get a accurate value. For that, I think approximate marks you are going to get. So how you are going to do, we'll be studying in this numerical analysis. So next, very good application we have. If you take a elastic, yes, spring in an elastic object used to store mechanical energy, we have to find the value between the two sets of values, and this technique is used to find an unknown value. So these techniques I'm going to tell you. So we are going to use this to find the accurate value. That is my main intention. Finite difference scheme can generally be applied to regular shape domain using the body fitted grids, right? So you can see so many things you just file and so many shapes you give, right? So for that also accurate value is required. Yes, how we are going to get the estimated value or accurate value? By using this unit you can easily find it. So how the shapes you can also find here by using this finite difference. And I would like to inform you that very very important, that this finite difference what you are going to study, we have a software known as a finite element analysis. Yes, students, to find the accurate answer and to get the accurate estimate the value, approximate value, right? We have this software also generated. When finite element analysis is applied to a specific field of analysis, it is referred to as finite element analysis. It means to find approximate solutions to complex mechanical engineering problems, right? So now you will be having very simple problems. How you go higher educations, like next semester you are going to become seniors, right? You should know how to find the accurate value, estimate the value, which is approximate solutions. You have to able to do this. So this software will help you. Yes, this is the most common tool for stress and structural analysis. Yes, this is useful. Most of the finite element analysis software today is extremely accurate. So therefore, just this was an introduction of how we are going to why we are studying this numerical analysis and finite difference. Okay, so we'll go back to our again definition. Yes, students. So what this finite difference definition we have? Consider a function y is equal to f of x. Yes, so you can just see we have taken one independent variable, as we have discussed that one will be independent variable, the other will be dependent variable. So y is equal to f of x we have taken here, right? Let x0, x1, x2, and so on be the points at a common interval h. Okay. Let the corresponding value of y is equal to f of x be y0, y1, y2, and yn. So means what? The independent variable x is called here argument, and the corresponding function value is known as entry. Means x is known as argument and y is known as entry. Okay. So here you can see, if I suppose the interval they have given like 1 is there, 2 is there, right hand side I'm writing 4 is there, 5 is there, right? So suppose you can take this as some value of x, right? And they make you value of y. So this depends, right? So x is our independent variable. Depending on this y you are going to calculate, that is f of y1, y0, sorry, f of y1, and so on, you can calculate very easily. Okay, so here I would like to tell you the things that whatever the first value we are going to take, we are going to call this as x0. Next is x1, next is x2, and so on. So corresponding values, what are corresponding values? That is y0. So this is our y0, which is equal to f of x naught. Okay, y1 f of x1, right? So here we have y2, which is equal to f of x2, and this will continue. So here corresponding values we get. What you have to remember is there is x independent variable where we have entries or the set of points, what we say, x0, x1, x2, and x3, and x4. Here you have to again come, we will come across about the interval. So difference between 2 and 1 is 1. Difference between 2 and 3 is 1. So difference between 3 and 4 is 1. And difference between 4 and 5 is 1. Means here the common interval h is equal to 1. You'll come across this. Okay. So you will can find h value. You're going to get the set of points. Okay, then you will find the corresponding values, they are y's, right? So all this you are going to simplify. So you can see, you can find the finite difference. So it is finite. So what is the difference? Difference is 1, which is finite. Just understand the meaning, they are known as finite difference. Okay, so next we will go to the interpolation. So we have interpolation. What is interpolation? We'll just see. Yes. So this is our interpolation, right? Just make here. Okay. This is interpolation. Suppose we are given the following values. So this is exam point of view, as you remember that, very, very important. So here we see they have given some values here, students. Y is equal to f of x. Okay, for a set of value of x. So you can see here they are x0, x1, x2, x, and they have given corresponding values y0, y1, y2, and yn they have given. Then the process of finding the value of corresponding to any value of x between x0 and xn is called interpolation. Okay, so simple. Whatever we have done here, finding this differences, right? 2 minus 1, 3 minus 2, 4 minus 3, and 5 minus 4, and this will continue further. So finding these things, right? First x will be given, find x, y, and for that again we find the difference, we find the interval, common interval. So you can see we got the argument, we have entries, and we have a common interval. So doing this, all the things, we just say this things doing is nothing but interpolation. So because this is in the interval 1 to 5. Okay, finding the value from 1 to 5 or in this interval is nothing but interpolation. Okay, then we have the thus interpolation is the technique of estimating the value of a function for any intermediate value of the individual independent variable while the process of computing the values of function. Yes, so this is what we know about interpolation. Suppose if you want to compute the value outside this function, means if you calculate the value inside this interval, I will just take 1 to 5, then we say this is interpolation. Suppose if you want to calculate 6 and 7, right? Outside this interval, then we take this as extrapolation. So please remember, this is extrapolation if it is outside the interval. Inside the interval, it is interpolation. Okay, so remember interpolation and extrapolation. So thus the study of the interpolation is based on the concept of difference of a function, which we proceed to discuss. Okay, here we are going to discuss. Here, please remember, in this difference, again, we have two types of differences. One is the forward difference, and the next is the backward difference. So we can see here we have forward difference. The difference what we are going to have forward is y1 minus y naught, y2 minus y1 till yn minus yn minus 1, where we denote this by delta y naught, delta y1, delta yn minus 1 respectively. So this, we consider this as first forward difference. Suppose if you want to calculate second forward difference, then we take here, yes, it is delta square y naught, delta square y1, right? And this will continue. This is second forward difference. So these are nothing but the forward difference. So this you can see delta is nothing but our, yes, students, it is forward difference operator. Please remember this, at delta is nothing but our forward difference operator. So you can see we have this forward difference table. So I will tell you, see here, the value of x will be given, right? Corresponding value y we have. So we are going to find this first difference, right? Second difference, third difference, fourth difference, five difference, continue like this. Okay, so how you find this difference? Yes, you can see here very carefully. This table is very important, students. Yes, now you can see the difference between this y1 minus y naught. As I told you, here you can see y1 minus y naught is nothing but delta y naught. So this is our first difference. So just subtract this, you'll get first difference. So we'll continue like this. You'll get y1, delta y1, delta y2, y3, and delta y4. Similarly, we'll continue for the second difference. So what you do again, one example I'm showing just, remaining you can continue. Second difference is denoted by delta square. Yes, forward difference table. Now what will be the difference? I will just write here delta square y naught. How you can calculate? By delta y1 minus delta y naught. Similarly, you can go for delta square y1, delta square y2, delta square y3. Okay, you can continue this. Next, we go to the third difference table. You can see very easily, students. To calculate delta cube y naught, what we do? Yes, we take delta square y1 minus delta square y naught. This process continues till, so some you may ask that, sir, till where to we are going to continue? Till we get the last, in the last difference, you must get a single value or only one value you must get. Then we will stop this process. So you can see we are going to get here first forward difference table. So this is known as forward difference table. Okay, so this is one, type one. Next type we have backward difference, student. So what is here? Yes, here we are going to take again the difference is y1 minus y naught, y2 minus yn. Yes, we denote it by daba. Daba y1 is the first backward difference. So this is daba y1, daba y2, and daba yn you are going to get here. Okay, so here respectively we are going to get this first backward difference. So here again daba is nothing but our backward, yes, it is backward difference operator. So please remember here, yes, here we have backward difference table. Please note down, this is very important. Here again you can see this is x and this is y. So backward difference we will be taking here from down. So y5 minus y4, you will get here daba y5. Okay, so we'll just write here one by one. I want to calculate daba y5, which is equal to daba y5 minus y4. So similarly, you can continue for the remaining. First, backward difference. Okay. Next, I want to calculate daba square y5, right? So I will just take the difference, and it is daba y5 minus daba y4. Okay, so this is a backward difference, so we are going to go for backward difference. Okay, so I want to calculate now the third backward difference, so it is denoted by daba cube. Okay, this is y5, and therefore this is daba square y5 minus daba square y4, and this continues till where to continue. Please remember to till we get the last single value, this difference table will be continued. Okay, so next, after studying this finite difference and then estimating the values, then we, after studying forward difference, backward difference, this doesn't stops, right? So what Newton did? Yes, he found out the accurate value by using forward and backward difference. He calculated the forward interpolation formula. So therefore we know it is known as Newton's forward interpolation formula. So people don't keep quiet, right? They do go on searching the things, coming out the accurate best values, estimating the best values, right? If you do any experiments, you can see you try to get the best value or accurate value. You can see very mechanical engineering, everyone will carry on these experiments, right? Those who get the correct and accurate value, I think you have come across, you will get full marks, right? You will get good marks. That is what I say. Okay, so here Newton, what it did, yes, he conducted this experiment and he has estimated a very accurate value by using this formula known as Newton's forward interpolation formula. So he says that let the function be y is equal to f of x students. Okay, take the values y0, y1, y2, and so on. Corresponding values x0, x1, x2, and so on. Suppose it is required to evaluate f of x for x is equal to x0 plus h ph, where p is any real number, then we just take this as yp is equal to y0 plus p delta y0 plus p into p minus 1 upon 2 factorial delta square y0 plus p into p minus 1 p minus 2 upon delta 3 factorial delta cube y0, and so on, students. So you can see very easily Newton's forward interpolation formula. This is helpful again to estimate the accurate value, to approximate the value, right? To get the accurate value, we will be using this Newton's forward interpolation formula, and very important formula. This is a very important formula in numerical analysis. So please note down. Again, Newton did not stop here only. He get back to the backward interpolation formula. So he says that let the function be y is equal to f of x runs. Okay, take the value y0, y1, y2, and so on. Corresponding value x0, x1, x2 you will get. Then the required value, you can see f of x for x is equal to x0 plus ph, where p is a real number. He says that yp is equal to yn. See here it is y naught is there. This is for forward. Now it is backward. So please again remember the difference between forward and backward. Yn plus p daba yn plus p plus 1 upon 2 factorial daba square yn plus p plus 1 upon p plus 2 upon 3 factorial daba cube yn, and so on. So this is known as now Newton's backward formula. So these two formulas are very important to simplify the example, students. So please note down and we will solve the example. Is it clear? Okay, so this is a small introduction or a brief idea about finite difference. Yes, difference table, forward difference, backward difference, Newton's forward interpolation formula, Newton's backward interpolation formula. So we will simplify the example here. Okay, we will try to simplify this example. Yes, you must be now writing here. So in this example, you can see very easily, students. Okay, please write down. Find y 1.4 is equal to y of x is equal to y of 1.4. See, in the exam, they may give you y 1.4 4, right? You can easily find out x value is 1.4. Let them give, instead of this, they may give y of 1.4. You can easily see x is 1.4, means you are going to calculate this value, right? um so before example, I always give the method. So just see the method here. Yes. So we are going to, whenever the question is given, students, okay, construct the difference table with interpolation. This is very, very important. As we have discussed, how we are going to find the interpolation and how we are going to find the difference table, right? Compute the value of P. So there are again two cases here to compute the value of P. Please note down this. P is equal to x minus x naught upon h in case of forward interpolation. Yes, whenever it is forward, P is equal to x minus x naught upon h. Okay. So when it is backward interpolation, please note down P is equal to x minus x naught upon h for backward interpolation, where x is the value which we have to find out, or which is given to find the value. X naught is the value which is a first value of x. Is it clear? Xn is the last value of x, and h is nothing but our step length. So please remember these things. Then we go to the step 3. We say all these values I'm going to substitute in the formula. So what formula? Yes, it is Newton forward interpolation formula and Newton backward interpolation formula. So we get the answer. What is the answer? Approximate answer we are going to get here. Okay, then we will solve this example. Is it clear, students? Okay, let us try now. Yes, please be ready with the calculator also, because you can see here it is quite helpful to simplify the example. Okay, let us
So, can
start now.
you please go to steps once again?
Okay, thank you. Yes, this is because this, if you understand, you can do any n number of examples you can do. So please write down first, construct the table, keep this in your mind, fix in your mind whenever they give the numerical analysis, the table, your first thing in the interpolation, you are going to write the table. This is very, very important. Next, you are going to compute P. So there are again two types. Forward interpolation, we have P is equal to x minus x naught upon h. And for backward interpolation, we have P is equal to x minus xn upon h, where P is a real number, okay, that you know already. So x is a given value, x naught is the initial value, xn is the last value, okay, h is nothing but the step length. Then all this value you are going to substitute in the formula, that's it. Only 3 steps are required. Yes, this is quite easy and simple. Then we will go to solve the example. Okay, shall we go to the beta? Next example will shall we solve?
Yes, sir, no problem.
Yes, thank you. Okay, fine. Here the example. Okay, we'll solve the example quickly. So first step, it is step 1. Constructing the table. Okay, we'll construct the table first. Okay, I will write like this. Here's the table. X is given and y is given. So we'll just first write this first 1, 2, 3, 4, and 5. Here we have 10, 26, 58, 112, and 194. So we are going to first construct this table by using the forward and backward difference. Okay. So can anybody tell me which difference table I have to use? This is a very important. Which you are going to choose is very, very important. Yes. Can anybody tell me, should I use forward or backward? I have given already the idea.
Forward.
Anyone? Yes, beta, you are right. It is forward, because looking at this, so this is very, very important. Which to choose? If you choose wrong, your marks are gone. So looking at this given x, we have to find for 1.4. So 1.4 is between 1 and 2. Am I right? Yes. So this is above, means it is here. It is above 1 and 2. This is between 1 and 2. So therefore, whenever it is above the middle line, then we are going to use Newton's forward interpolation formula, students. Okay, just this is a trick to find. There is no other way to do. This is the only way I think you can easily find out is you are going to use forward or backward interpolation formula. Okay, so when it is forward, when we choose forward, so the first difference you are going to take is as delta y, which is nothing but you can just take this as first FD, forward difference. Okay, so delta y is our forward difference. So I'm going to difference now. Yes, please start calculating the forward difference. So I will just give you the here. This is delta y naught. Formula is y1 minus y naught. So you can just note down this. This is x naught is there, x1 is there, x2 is there, x3 is there, x4 is there. This is y naught is there, y1, y2, y3 and y4. Okay, use this formula y2 minus y naught. It is 26 minus 10. Please tell me. Please tell me the answer. Yes, students, please calculate. Yes. So delta y naught is equal to 16. Similarly, go to the next one. Delta y1, sorry. So again 58 minus 26. Please tell me what is the answer.
32.
32. Very good, beta. Next, go for delta y2. Please tell me 112 minus 58. 112 minus 58 is 54. Okay, so like this, you are going to write the difference. Okay, so you can not required every time to write this formula. You can easily understand now how the difference table you can do it. So this is for your understanding. I have given the formula. Okay, so here we have right. So next is 54. Next difference is 82. Please check the answer. Yes, this is the first forward difference. I will go to the now second forward difference, that is delta square. It is denoted by delta square y. I'm going to find the difference between 16 and 32. 32 minus 16 is very simple, 16. Next difference you can see 54 minus 32. Yes, please. 22. Check once again. 82 minus 54. 28. Please check. Okay. This process will continue. Third forward difference I will go. This is delta cube y is there. So 22 minus 16 means 6. Here we have, right? And then 28 minus 22 is 6. Then we go to the fourth difference. Therefore, delta 4 raised to y. Okay, so there we can see 6 minus 6 is 0. So that's it. Here we have finished the constructing the table. This is quite easy. Just subtraction is there, students. Everyone must do this table. Is it clear? Am I right? Shall we move to the, this is step 1. Construct the table, just subtraction. Okay. Then we will move to the next step 2 I will take here. So please note down what is step 2. Can anybody tell me what I have to do? Step 2, please reply. Yes, I have to compute.
Compute P.
Compute P. Anyone has just discussed anything? Okay. Compute P. So again, which formula I'm going to choose? Very, very important. This is forward difference. So formula for forward difference is P is equal to x minus x naught upon h. Am I right? So what is x here? X is given always. Please remember x is given. Therefore, x is equal to 1.4. Okay. X naught is in the table. Please remember, in the table it is first first value. It is also known as first value. See, I'm writing everything on the right hand side. You can see x naught. Therefore, x naught is equal to 1. So here you can see x naught is 1. They're already there. So then we have h. Can anybody tell me what is h? H is a
Step length
One.
equal to 1.
very good. It is 1. Step length, it is interval also we say. Difference between this 2 minus 1 is 1. 3 minus 2 is 1. And 4 minus 3 is 1. 5 minus 4 is 1. Therefore, h is equal to 1. Very good. Excellent. So you have understood now. H is 1. Fine. So use the formula now. Next is step 3. Only 3 steps are there. Use the formula, substitute the values, and tell me the answer. Yes, who will get the answer? Let us see. And just use the forward difference formula, right? I'll just take this formula here. Yes. This formula, please use and substitute the values. Okay, so I will take this now. Yp is equal to, I have not calculated p value, put it in p value. This is 1.4 minus x naught is 1 divided by h is 1. So this is 0.4. So p is equal to 0.4. Substitute all the values. So this is y 0.4, right? So this is equal to y naught. Y naught is already given here. Y naught we have 10. So here we have y naught value. Okay. Next, I will just so what I'll have to substitute, I'll just rewrite it here once again. P is equal to 0.4 is there. Y naught is 10. Delta y naught I have to substitute. Just where is delta y naught? Here is the delta y naught is there, right? Then delta square y naught I have to substitute. Delta cube y naught and delta raised to 4 y naught. So therefore this is 16, right? And delta square y naught is also 16. Delta cube y naught is 6 and delta raised to 4 y naught is 0. Substitute the values here, students. Fast. Therefore, you can see this is by 0.4 is equal to, this is 10 plus 0.4 delta y naught is 16. Yes, please tell me what is the answer. Delta square y naught is 16. Just I'm substituting the value. So it is p minus 1 is 0.4 minus 1 and this is 0.4 minus 2 divided by 3 factorial, right? And this is delta cube is 6 plus 0 because delta raised to 4 y naught is 0, therefore remaining terms are 0. Please tell me what is the answer. Just simple calculation is there, put it in the calculator and just simplify and tell me. Anyone? Please unmute and tell me, but I cannot see the chat box. Yes, please do it fast. Okay. So just check. Everyone got this answer? 14.864. So that's it. Only in the three steps you can solve this value. Y of 0.4 is equal to 14.864. Everyone got the same answer? Yes?
Calculating, sir.
Okay. You can put it in chat box also. Okay. Should be put in calculator first. Okay, then
Sir, the question again. The first one.
yes, beta, any doubt?
Here they have told us to find y of 1.4, but we are finding y of 0.4.
Yes, students, you got the answer? Yes, any doubt, please?
Sir, I'm getting 15.5.
Okay.
No, sir. Same answer. It's right, sir.
Okay, fine. So this is y of 0.4, 1.4. Okay, so this is 114.864. Or this is also written like this. Y of 1.4. Y of 1.4, right? Y of 1.4. It is written like this. So let them ask. Continue with the same procedure, students. Okay. So nearly you should get it 14. Where this went? Okay, fine. Will you do for the next example? Let us see how many will get the answer. It must be fast than what I solved. Okay, so try everyone. Start solving the next example. Yes, any doubt? Please, it is open. Ask your doubts. Don't keep your doubts with you. So, okay, we'll start solving the next example. Okay, you can see here they have given 0.5. Here x is again 0.5. You have to find, and y of 0.5 they have given. Here again x is 0.5. Okay, directly also they have given x is equal to 0.5. So both the anyways, let them ask in any type, in any ways they may ask. You have to choose x is equal to which term. That is very, very important. Okay, so please start solving the example fast. You must be fast. Go for the step one, students. Step one. Yes. constructing please tell me, is it a forward difference or backward difference I have to do? Anyone?
Backward difference.
Yes, it is backward difference. Everyone agreed? Okay. Yes, students, please see. We are going to solve this by backward difference. Please tell me why it is backward difference. Any idea how you have understood by why it is backward difference?
X is 0.
X is 0.5. 0.5 is above or below?
Below.
Huh? X 0.5 is below. I doubt. How you have calculated? See here, X is between. Please remember this. X is between 0 to 1, right? Here we have X naught as X1, X2, and this is X3. Why this has appeared here? Okay, fine. So this is between 0 to 1. 0.5 is between 0 and 1. And it is above or below?
Above, sir. I told that it's below that minus. It's between 0 and
Okay,
1,
okay.
sir.
Okay, so this is above this table you have to see beta. X is 0, 1, 2, 3 is there. 0.5 will come in which, above or below? If you take this as middle line, right? If this is middle line, please remember here, students, everyone, I'm repeating again and again. If you take this as middle line, X 0.5 is above this middle line. If it is 2.5, then it is below. Is it clear? So these things you have to be careful. This is a range, right? Please remember this range first. Range of X. Range of X is 0 to 3. Please remember this. The range of X is 0 to 3, and it is 1, 0, 1, 2, 3. Okay, this is the range. In this range, X is equal to 0.5 is above. So this is not backward difference. This is, you are going to use forward difference. Okay, start simplifying the forward difference. Let us see how many will get the answer. So I will just give you this hint. X, and this is our Y, right? This is 0, 1, 2, 3. This is 2 to 5. This is 238, and this is 320. Please simplify and tell me the answer. Yes, I'm waiting for the answer. Okay, I will go for the first difference known as delta y. Okay, this is our first difference. Yes, as I that you're going to take the forward difference. So therefore, difference between this 238 minus 225 is 13. Please check difference between these two, right? Then we'll go to the difference between 320 minus 238. Please check 382. Yes, difference between 340 minus 320, is it 20, right? So this is first forward difference. Next we'll go to the second forward difference, that is delta square y. Just take this 82 minus 13, is it 69, you will get, right? So again, difference between 20 minus 82. Please see, this is the ulta, that is 20 minus 82. This is minus 62. Don't write here again plus and don't get confused. Do it only, you can go through the formula also I have given already. Then I move to the next, that is third difference. Then you can see this delta cube y, that is the third difference. You can see this is, I will write here, don't get confused. Minus 62 minus 69 is equal to minus 131. So difference between this means minus 62 minus 69 will be minus 131. This is our difference table, students. Okay, so therefore again you remember x naught, this is y naught, right? This is delta y naught. This okay, this is delta square y naught, and this is delta cube y naught. In the difference table we will be taking this values. Okay, now please simplify the step 2. Tell me what is p value. Yes, p is equal to x minus x. Yes beta.
0.5.
Yes, very good. So you should be fast like this. What is x here? X is 0.5. X is 0.5 minus x naught is 0 divided by h. H is 1. So therefore this is 0.5. Okay, step 3, use the formula. Please use the formula for difference table. I will take the formula again. Right? You can write down the rewrite the formula once again. Okay, use this formula, students. Quick, substitute all the values. Yes, just take it here. Okay, so as you know, you should know all the values. So therefore I will take this as y of 0.5, or we also write this as f of 0.5 also, which is equal to, or we also write this as y of 0.5 is equal to, so I'll substitute all the values. So 225 plus 0.5 13. C, I have marked here delta y naught. Yes, so p is 0.5, delta y naught is 13, plus this is 0.5, 0.5 minus 1 upon 2 factorial. Delta square y naught is 69, plus this is again 0.5 in the bracket 0.5 minus 1, right? So should be fast. You can calculate very easily. Your calculator is made very easy. So 0.5 minus 2 divided by 3 factorial, and delta cube y naught, I think you have got here minus 131, and so on. So you cannot go further. You can see delta cube y, no, y we get, delta 4 we don't have. So we'll stop till here. And now please tell me what is the answer you have calculated. So this is y of 0.5 is equal to, here they have given 0.5 only, ne? X is also 0.5 only. Yes, y here. Yes, okay, no problem. See, this also differs, huh? X value they will give different. Don't get confused. Simple calculations. This is, students. Please tell me what is the answer.
214.6.
Yes,
214.68.
That's it, beta. You got the correct answer. Excellent. Please check everyone. Everyone is getting the same answer.
Yes, sir.
Yes, sir.
Okay. Yes. So that's it. So like this, you should able to use the Newton's forward interpolation formula and Newton's backward interpolation formula. So next class, I will just see. We'll go with the backward difference also. Yes, students. Any doubt? Simple calculations. This is numerical analysis. I think everyone have understood very easily. Was quite easy. Yes. If you have any doubt, please ask me.